Okay, today we're going to talk about control flow and loops, and we'll go through certain concepts as to how we've learned about how the typical data types we've used, like why we are not explicitly defining variables, how do we use variables, how do we use expressions, how do we write statements. So that kind of part we have covered. Now we look at how do we write a program or a script, um, like to work as a section, right? So how do we do that? So we look at that today, and in the next class we look at functions and methods and classes. So that's until we get there we cannot write like complicated programs. So let's get started today. So the control flow is where uh, Python understands how we write like three lines which say print 1, print 2, and then print 3. So Python sees three lines. What it does is it executes the first one, then it goes on to the next one, and then executes the third one. So when the Python interpreter looks at these three lines, then it has to first execute this one, complete that, then it executes this one, then it completes that, and then it executes this one. But what if we are writing some code that is multiple lines? So I'm writing something which takes like a very long string and it doesn't complete there, so that would mean that I would have to extend it over multiple lines. Otherwise, I have to scroll right to see it. So if that is the case, there are some ways Python allows us to continue the code in multiple lines. If you want to write one line of code, but you can't really do it in one line, we use something called an implicit line continuation or an explicit line continuation. So let's look at implicit line continuations. Implicit means we don't tell the interpreter that we're actually continuing it. We're just doing it and Python or the interpreter understands it, that we are actually having this as multiple lines. So if you look at the first line alone, it says a equal to square brackets open. Square brackets actually is a list, as we have seen earlier. So we are opening and starting a list, but there are no elements in this list. It's not ending the list. In this line, there's nothing else that the Python understands. So the interpreter waits for the other part of the list to be completed. It goes to the next line. It sees that we're opening another list and then completing it. So this is the first element of this outer list. That in itself is a list. And then there's a comma. That means this list is not complete yet. So it goes on to the next line. It sees another element, which is a list. And then there's another comma, which means the list is continuing. And then it goes on and it goes on until here it knows that the list is not complete yet. So these kind of like continuations where we write code in multiple lines are called implicit line continuations. You don't have to know this theoretically what the name is, but just to understand that interpreter thinks of it differently, right? That is a concept you need to understand. And it's like earlier I've showed you that we can write multiple lines of code as well. Like we can write x equal to 1, y equal to 2, z equal to 3, and then have semicolons. We can have print statements separated by semicolons. That would actually mean those are different lines, and Python does it as though you write it in different lines. So Python can do that, but in the Python world, this is not considered good code, or a Python programmer might come back and say, "Oh, this is not Pythonic." So they might come back and say this is not Pythonic. So if you hear that, what that means is it's not a good convention to write code this way. Rather, if you want to write multiple lines of code, uh, like write it in multiple lines. That is like x equal to 1, y equal to 2, z equal to 3, and so on. So this is a better way to write code. And also, like, to understand a more Pythonic way of writing code. So if you have to have three assignment statements, you want to assign 1 to x, 2 to y, and 3 to z. You could do it this way. So you could set it up in one line, by doing x comma y comma z is 1 comma 2 comma 3. That the first value, um, 1 would get assigned to x, the second value 2 would get assigned to y, the third value 3 would get assigned to z. And when you also do a print, you can just do all three elements and say use a separator as a new line. So this is actually a new line character. What that means is it moves it to the next line. If you do it this way, so then these three elements get separated by three different lines, and then we are able to print it. So you can get the similar result as this, that you wrote like this in this statement, or by using this statement, this set of statements. So you could do it that way as well. So there are multiple ways to do it. So these two are more Pythonic, whereas this one is not. It's not considered a good way to code. Okay. We looked at implicit line continuations. That means we open a list or we open a tuple, and then Python knows that we are actually, the code is still continuing. In this case, right, when I say x equal to 1 plus 2, as soon as this is complete, Python thinks x has to have the value 1 plus 2. That means it has to be 3. But if we actually have a plus symbol here, and then say plus 3 plus 4 plus 5 plus 6, Python wouldn't understand what this is. So it will actually throw an error saying, I don't understand what this plus 3 plus 4 is. Let me try what happens if I do this. So if I write the code as x equal to 1 plus 2 plus 3 plus 4 plus 5 plus 6, in our mind, when we read it, we think, okay, probably it's a 1 plus 2 plus 3 plus 4 plus 5 plus 6. So we might be able to interpret it that way. But a computer, the Python interpreter, may get confused. After the first line, it may not understand what is there. So it doesn't understand that piece. And like it might throw errors. And in this case, it's actually thinking it's an indentation error. But yeah, so here is where it doesn't understand that there's no space after the plus. Why is there no line ending here? So it doesn't understand the next line is actually part of this. So that's kind of where we have to use something called explicit line continuation. That is, we use this backspace, backslash, to actually tell Python that we are actually continuing this in multiple lines. When you write code, like typically you want to have a long string, you want to write something and assign it to something, then you would have to use this like continuation, and then you will use a backslash to do it. So if you do it this way, Python understands that it's everything together goes in one line. So whenever you say this, it understands that, oh, I'm supposed to, the Python is supposed to look for more commands from the next line, more part of the command from the next line, so and then it can do that. In this explicit commands, that is, when you use backslash and add more lines, you cannot add a comment in between here. This would not be understood by Python. So like if you say I'm going to continue the line here, Python does not expect anything else to come in the same line. So it doesn't understand that. So commands are not like allowed in this particular scenario. What if I want to write multiple lines of comment, and I want to like, we know that in Python when we write comments, when we put in a hash, say we say print 1, and then we want to do a comment, we can just say this is a comment, or you can say this prints 1, or you can just have the below code does this. So you can do it that way. So this is the way you could put in a comment, this is the way you can put in comment. If you want to write multiple lines of comment, this is the way you do it. So you open single quotes thrice, and then it for example, if you are using a Python compiler and you do 3 quotes thrice, it automatically adds the end 3 quotes. And here you can add whatever lines of code you want, comments you want. Line of comment 1, 2, 3, you can go on. And this will give you end of block, and you can write your comments there. So now we saw how we write code in multiple lines, and how Python executes the first command, command in the first line, then the second command in the second line, then the third command in the third line, and so on. If we want to change the order of the way Python executes it, then there's something called Controlflow. I think we've used if conditions earlier, but we probably did not relate it to what a Controlflow is. So if you look at this, if we say if 2 is less than 1, then do this, and then we say else, do this. So we want to check a condition, and then based on the condition, if it's met, it will do all these indented lines. If you see, this code block is actually indented by one tab or by 4 spaces. Similarly, this is also indented by 4 spaces. So if you want to, if this condition is met, this block will get executed. If this condition is met, that is, this condition is not met, then it go to else. Then this block is executed. So here I have only one line of code. I can also have multiple lines of code, just like the previous one, and then that can that can all be executed here. So here I'm having a condition where 2 is not less than 1. So that's what it's doing. So if you check a condition where it does meet, so the first block of condition will get executed. I'm sorry. Equal to 0 is an assignment operator. Double equal to is actually checking whether it's equal. So here I see that this block of code is executed, and I can see those lines printed here. So that is one portion of like the control flow, right? That is how we don't have all these blocks executed every time, or these blocks executed every time. It depends on this condition, and based on the condition we execute it. So those are if you want to do certain things where we want to do it in a certain way, in certain condition you do this, in another condition you do this, then we use those if statement logics. Let's try this. Say if I want to do something like if somebody presses a, that means they're an admin. If they press a E, they're a editor. If they press a G, they're a guest. And then if there's a wrong entry, it prints out wrong entry. So we can use a similar if condition for that. And here I'm introducing something called else if. So else if is where the first if condition is not met, and then it does another if condition. So it checks whether this is true. So it would come here only when the first if condition is not met, and then it checks if this role is E. First, if the role is, like, let me try like as it was earlier, right? T. Let's try that. So in this case, what will happen is role is T. First, it'll check if role is A. It's not, so it'll go here. It'll go to the else if condition, and because it's an else if, it will check if this condition is true. Role is role, that is T, is equal to E, which is not true. So it wouldn't execute the next one. It will go on, try the next one. That's not true as well. Then it goes to else. So here we can use one else condition, and you can use multiple else if condition in between. So we have seen if else. Now if you want to use if, else if, and else, then here, like this example, there are two else ifs. we can have multiple else ifs in between. At the end, there can be only one else. You can have the code without else, like this would work too, but this catches all the condition where none of these conditions were met. Then it'll hit this condition, and then this part will get executed. So in this case, that's what we expect, because t is not a, it's not equal to e, not equal to g, so it has to be an else condition, and we believe it will send out the entry that it's a wrong entry. So that's the part where we look at if, else if, and else. What if we are actually working with nested conditions? So if you want to do something called nested, so in this case, everything was at the first level, and we checked everything. In case you want to do something called a nested else, if else, so what we would do is, say in this condition, we're going to try G. Here we are checking if the role is in A, E, or G. If that is true, this block would get executed. Inside that block, there is still an if condition. So that's why it's called a nested if. So this is called a nested if because we have an if condition inside another if condition. So if you actually look at this is a if, this is its else block. But within this if, there is another if condition. There's another else condition. So this is a nested condition. Within this else, I can see that there's another if condition, another else condition. So this if, this else, that's the outer loop. Inside this, there's a nested if, which has this condition, and if it does not met, if that does not get satisfied, then it goes here, and that is at this level. That's a second loop. Inside this, there's a third innermost loop, which is another nested if. So this is how a nested if works. So nested if is where one of the condition is nested inside another one. So in this condition, let's try what's happening. So we ask the person to enter A, E, or G. The person enters a G. Then we check if that is present in this list A, E, or G. So this square brackets means it's a list, and it has 3 strings A, E, or G. So this one means role in list, means that it's checking if this G is part of this. So G is in this list. So G is in this list. So that becomes true. So it wouldn't execute this. It would go inside this block. Now within this block, the first statement itself is an if statement. It's checking if the role is A. It's not. So it goes to the else condition. Within the else condition, there is this block. So it has to execute this block. First statement of this block is if role is equal to E. Again, that's not true. So this block wouldn't get executed. It will go to the else part, and then it goes here, and then it prints guest. So that's what we expect it to do. So when somebody presses G, they press it prints a guest. Whenever somebody presses E, it presses editor. It types out editor, and then when somebody presses something invalid, it says wrong entry. So that is how the nested if works. Now before I go on to while loop, I want to stop and ask, how are we doing? Do you understand this piece until here? Prem, all good?
Yes, sir.
Yeah, let's move on.
Okay, sir.
Next is the while loop. While loop is another place where we actually don't execute it line by line, but here it allows us to actually do it multiple times. So it's something called looping in programming. If you're not aware, what it does is it allows you to run a block of code. So this is a block of code. So here I have 2 lines. We can have like 20 lines. We have like 200 lines. But we can have a block of code execute multiple times. And we can have it execute multiple times until some condition is met, or until like we finish some execution. So we can repetitively do it, iteratively do it. So that is what that's the use of a loop. And within loop, we're going to look at two loops. One is a while loop and a for loop. But let's start with the while loop. Here what we are trying to do is we want to find the sum of the first 10 numbers, integers. So all number that um, that are starting from 1 until 10. So here what I'm trying to do is I'm having the last number 10 assigned to num. At first I start with the sum is 0. That is, now I'm starting with 0, and then I'm going to add the 1 first, and then 2, and then 3 to some, then 4 to some, and then 5 to some, and so on until 10. That's what I'm trying to do. So I'm going to start with 0, and then this is my counter that I'm going to use to count from 1 to 10. Here what I'm doing is I'm going to run this block. When I say while I is less than num, I'm going to keep running this block until like I is equal to, less than or equal to 10. I mean, in this case it's so this piece of code executes until I is less than or equal to 10. So this condition that we're checking here, what it does is it makes sure that until that condition is met, we will always keep running this loop. So we will run these two statements which are part of this block, and at the end we'll print the value of sum. So at starting it was 0. After that we're adding the I into it, and then we're incrementing I by 1. That is, we're at first it will be 1, then it will be 2, then it will be 3. So to make it increment by 1 each time, so we're adding 1, and then at the end we are printing the sum value. So that's what we're doing. So if I have a print statement and I print I and then sum, so that will let us know how the first value was, and second value was, and the third value was. So let's try doing that. So at first what happened was, let me do this earlier. So let me redo this. I want to print it earlier, and let's just print 1. So I think that might make it easier for us to understand at first. So what it does is, as soon as first I use 1, it goes inside, checks whether 1 is less than 10. It is. 1 is less than or equal to 10. It is. So it goes inside and then prints 1 for us. Then it adds sum, that is 0, to 0 plus I is 1. So it now sum becomes 1. After the first loop, sum becomes 1, and then I becomes I plus 1. That is, I equal to 1 plus 1. Then it becomes 2. So now it's 2. Now it goes back to the while loop. Now here it checks if 2 is less than or equal to 10. That would mean it still is meeting the condition. So it prints it, and then goes for the sum, and then goes on to the next number and the next number and the next number, and it goes on until it's 10. What happens when it's 10? When I is 10, it will meet the condition still. 10 is less than or equal to 10. Yes, it is. So it will go ahead and print 10, and then it will make the sum equal to sum plus 10, whatever sum it has until now, and then plus 10. And then it becomes, I becomes 11. Now it goes again to the loop. 11 is less than or equal to 10. I is 11 now. Numbers is always been the same, 10. It doesn't change. So 11 is less than or equal to 10 is not met. So that means it stops executing this. And then it goes to the print statement, and then it prints the first 10 numbers, and that value is 55. So that's part of how like this whole loop happens. That is the execution of the while loop. And something which is pretty common and what I use all the time is the for loop. So this is pretty important in our logics that we are going to use. Here, what we can do is we can do the same kind of iteration. We can do a block of code running multiple times, just like in the while loop. We can do it, and we can. There is no condition check in the top. Rather, there is a list or a set that is that we have, like we have a list or a range or something like that here, and then based on that we iterate in this block. So we'll see how this for works. That will probably give you an idea. Say we have a list of numbers 1 2 3 4 5, and we want to iterate through those numbers and then square the numbers and then print them. So if you want to like if you have 5 elements in the list, I want to square each element and then print the square of that. So how I would do it is I say for I, or you can use any number here, x, I mean any variable here, I, x, k, whatever. I'm saying I in numbers, and numbers, if you see, it's a list with these 5 elements. So when it iterates, what will happen is in the first time I will be 1, the second time it executes I will be 2, third time it executes I will be 3, the fourth time it executes I will be 4, and then fifth time it executes it will be 5. And then I'm using square is equal to star star I star star 2. Yeah, the star star is actually exponent operator, just to remind ourselves what operator that is. And then I'm printing that variable and its square, and then I'm moving on to the next one. So if I execute this, this would come out to be how we expect. Like the value of I is 1, then it's 2, then it's 3, then it's 4, it's 5. Say I change this value to be like 300, 130, 143, 24, 15. That would just use that and calculate its squares. So essentially it just goes through the list, and each value of like the first value of I becomes the first value of the numbers becomes the first value of I. In the first time the loop executes, the second time it becomes 300, the third time it becomes 143, the third time is 24, fourth time is or the fifth time is 15. So it just goes through that iteration, and when you have a list, that's what happens. So we don't always have to do lists. Say we want to do the first 10 numbers, or in this case 0 to 9. There's something called a range function that we use. So we need to understand about the range function. So let me. So what is a range function? So the range function is something that that allows us to give numbers from a certain range. So if you look at this range object, you can give it a start, you can give it a stop, and then you get a range object back. Um, so you can give a start, you can give a stop, and then you can give a step. Like if you just give the stop, then the start becomes 0 by default, and the stop is what is the most default element. So for example, when we give range of 10, it assumes that 0 is the start, 10 is the end, and the step is 1. If you want to be a little bit more specific, then you can say I want to start in 1, end in 11, and then step to be 2, or let's say yeah, step to be 2. So we can do it that way. So if you look at this, it has a start, stop, and and a step, and then we can use all these elements as well. So it has a start and a stop and a step. Step means how much it uses to add to each element. Say for example, when you have step 2, then it becomes 1, 3, 5, 7, 9. And the step is 1, then it becomes 1, 2, 3, 4. So step is how much you need to get to the next element. So if you call the range function, what happens is you get an element like this. Like you get a element that is like, it starts at say for example, you give the start, you give the range as 10, just to keep it simple. That would get out the, I mean, it'll have a range object, but when you actually call the range object each time, then you'll get the values 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. 10 becomes the upper limit, it doesn't use it. It always starts with 0 and ends below the value we give here. So it doesn't include. If you want the first 10 numbers, then you have to give 1, 11. Then that would mean it'll start at 1 and then it'll go until 10. So the last element that we note here is not listed here. So that's how the way we do it. That's the way we have to do it. Okay, given that information, so now we know that range function gives a list of numbers, and you have to range function gives back a range object, but you can call the range object to get a list of these numbers. So let's look at how the range function works. So when I run print range of 10, it doesn't give me the numbers 1 to 10. It just gives me a range object from 0 to 10, right? That's all it gives. If you actually want to print the list, then you have to call the list function and then find range of 10 inside. List of range of 10, that would actually print the values 0 to 9. And in our example, if you want to have the first 10 numbers, then you give 1, 11, and then it will print the values 1 to 10. So if you want to get a list, then we do it this way. So yeah, there's another example where you want to start at 2, go until 8. Then we can you can have 2, 4. I mean 2, 3, 4, 5, 6, 7. You want to print those numbers. Then you can start at 2, go until 8. 8 is not inclusive, so it excludes that. So it's just 2 to 7. In the next scenario, we want to start at 2, count every 3 steps, and stop before 20. That is, 20 will not be inclusive. Stop before that. So it starts at 2, 2 plus 3, 5, 5 plus 3, 8, 8 plus 3, 11. So what if I give 21 here, or 22? Um, so that's a question some people ask. So let me work that out as well. So yeah, so 20 20 would still come in, but 23, because that's bigger than 21, that wouldn't come in. So when we give 20 here, it comes until 17 only. So 2, 5, 8, 11, 14, 17, because 20 is not inclusive. But when I give 21, then the 20 comes out, but not like anything bigger than 21. 21 or bigger does not come out. So that's a brief introduction to range. Now let's get back to the for loops. So for loop is where we started. Um, for loops can have else condition as well. So let's whenever we have an else condition for loop, and I don't use this in professional programming, but I think this may be useful in some cases. When you're done with your for loop, if you want to do something, then you can have an else condition, and we can print that out. Say for example, here we did this for loop. This is what we did earlier. Now if we add an else condition, we'll see what happens. After this whole list is executed, then the else condition comes in play, and then whatever is there left, you can print anything here. You can have multiple blocks of code here. You can do whatever you want to do whenever all your elements are exhausted in this particular piece of information. Okay. Now this is the most important piece. So we use for loop with lists. We saw that. We learned about range function. Let's see how do we really use range function, right? So if you want to do like let's do this. So earlier we wrote a while loop where we wrote a program where we found the sum of first 10 numbers. If you want to do it in a for loop, then we write it this way: for I in range 1, 11. That would mean the first numbers 1 until 11. 1 until 10, I'm sorry, it excludes 11. Sum, let's initialize sum to be 0, sum to be 0, and num to be 10. And here I'm going to say num plus 1, which is same as 11. And I'm going to do sum equal to sum plus I. So I'm doing the same thing as we did in the while loop earlier. I'm like writing that down, and then I'm printing sum at the end. Okay, so that was my mistake. So for I in range of 1 to 11, it does a sum for each of that, and then at the end it prints out the sum. So if we look at that, we did this similar to the while loop that we did. We started out with this. Earlier we had a while loop. We had two statements in it. But we summed sum equal to I, sum plus I, and we also did I equal to I plus 1. In this case, because we are using a range and we're using a for loop, the next value from the range keeps getting populated. So it doesn't have to, we don't have to actually do the, like we don't have to do I equal to I plus 1 like we did earlier. In while loop, we had to do this. We don't have to do this in the for loop because this has already been taken care by the range and the for loop. But we can get a similar result from that, similar to that. Let's look at another for loop with a range. So we saw for loops with list. We saw for loop with range now. This is another example of the same for loop with range. Here we're going to iterate through the first 10 numbers, 1 to 10. We're going to check if it's even, then we're printing even number. If it's odd, we're printing odd number. And say we want to also add a else condition in the for loop and say print all done. That would, after this whole for loop is complete, then we should see this getting printed. So let's look at that. So it went through the first 10 numbers. It said the first number is odd, even, and then everything was done, and then it said all done. And that is the for loop in itself. So if you look at that, the for and else are at the same level. Within this, anything that's here, how many ever, like if there's a for loop inside, if there's an if loop inside, multiple nested if loop inside, everything in together is part of this like this for block, and that will get executed multiple times whenever this for loop has to run, even if there are like 100 lines of code, like how many ever lines of code, right? Not just these 4 lines, you have multiple lines of code. That whole block, even if it has multiple if conditions, for conditions inside, for loops inside, it'll all execute to as one block, and then that will have to execute multiple times iteratively. Say you're running a block and you want to stop it, like you want to stop executing it. Say you want to meet, if you meet a condition, you want to stop doing that. Then what you could do is you could use something called a break. What a break does is it stops execution of the for loop. Here we are in a for loop. Inside that, I'm writing a break. That would mean the for loop that is closest will stop executing. There won't be any more iteration. So when we have to do I1 to 10 and then we break when it's like 5, let's do this. So let's do if I equal to 6 and then I break. So that would mean whenever it is 6, it has to break. So let's look at the program fully. So it runs from the range 1 to 10 because 11 is not included. Inside this is the whole block. First it checks if it's even. Then if it's even, it prints even number. If it's not even, it prints odd number. Within even, there's another if condition. If it checks if it's 6, and if it's 6, it breaks the loop. So even though we are running from 1 to 10, at 6 it has to break the loop. So that is what we expect out of this condition, and we see that that's happening as we expected. Let's move on. There is also something called a continue. Like this is where we don't want the remaining part of the iteration to happen. We just want it to like continue the loop, that is keep going on to the next iteration. In that case, we use something called a continue. Say we have a word with a lot of ends, and we want to count the number of ends. So here what we're doing is we're checking if the character is in this name. So what would it do is the first time it will be capital T, then it will be I, then it will be A, and then it will keep going through that loop. It will check if the character is not N. If it's not N, it will continue. If it is N, then it will add to the count of N's. And then it says total number of N's in this list is this, right? So if you go through this, we have multiple ends in this particular string, and whenever we have to count it, so this for loop, what it does is every letter in this, it takes it in char, and the char will be the first time it will be capital T, the second time will be capital small I, the lowercase I, the lowercase a, the lowercase n, and so on, and then it will keep adding to the count, and then we'll get the count at the end. What does this do is it continues the execution. Say for example, print. So here when we give a condition here, because there's a continuous statement here, it goes to the next iteration. It does not execute any below commands. Okay, 1 second. Okay, so let's move on. So if you look at that, so because there's a continue here, this command is not going to get executed for the ones that are not ends. So when it is not n, it's going to continue, so it's not going to print this command. So if you look at that, so there are 1 2 3 4 5 ends. So I'm sorry, how many ends are there? 5 6 ends. So we see 6 checked for ends, and we see the total number of ends is 6. If I remove this and we just have 2 ends, so it would only print it for these two things. So whenever the value was t, so whenever the value was capital T, lowercase I, lowercase a, it did not print check for n. So I'm going to like demonstrate that here. So when it was T, it did not do anything. It was I, it does not do anything. When it was n, it actually checked for n and then added to the count. Again, when it was n again, it did that, but it did not do it for the space, the S, the Q, the U, the A, the R, the E. So that is something you can check here. Okay, we are very close to finishing. We have like 10 more minutes. So let's look at the pass function. This pass function, pass command, I'm sorry, the pass command is something we use typically when we writing new code as a placeholder. So when we want to add some code into a function, so we're writing a new function. We'll cover functions in the next class in much more detailed way. But when we write a function, we want to have a placeholder, so we don't want to write any code. If I don't write any code here, it wouldn't allow me to, like when I'm defining a new function, my new function, and here if I don't write anything, I just have a code, it will not allow me to write any new statements. So if you look at that, it's going to error out saying that my definition of my function is not complete. So it did not expect it to be in the front indentation. It wanted it to be one level indentation down. So here if I have this, then it assumes that this is part of the function, so it will work. So here I'll be able to like the print statement is part of this function, and it took it to do that. But say you don't want Python to do anything, but you just want to put in a placeholder, then that's where we use the pass condition. Similarly, in a for loop as well, any place where we need indentation, for loop, if conditions, else conditions, any place, we put in a pass command, and the pass command is just a placeholder. We will just to know that, let anybody else know, or the compiler know that there's something here. It can ignore it, but for a person who's looking at the code, they'll understand that this is just a placeholder, and then we'll do something later. So here, if I look at that, it does a for loop 10 times, but it does nothing inside. So right now I'm just having it as a placeholder, and then I'm printing the command at the end. So that is the use of a pass statement. So here, if I remove the pass statement, the print is not working. If I put in the pass statement here, just like earlier, then it will work. So I just need a placeholder which is indented there, because there's a for loop, because there's a definition of function, if there's a if there's a else. In all those cases, it would require us to do that. So that's the reason we add those examples there. Okay, so let's look at today's assignment, and we'll see that we are able to do something today. So today's assignment for class number 5 is going to be slightly tougher than the earlier problems. So let's look at that. Let's um, okay. So what we're planning to do today is to be able to remove something called duplicate zeros. So that's today's assignment. So we'll look at that. It's called duplicate zeros. What we want is, we are given an array uh, like this. We're given any kind of array like this. What we want to do is, we want to duplicate each occurrence of 0. So whenever there's a 0, so if you look at this is what the input is. We want the output to be exactly the same, but with repeating zeros. That is, I take this, here there's a 0, so I'm going to make it 2 zeros. Then here there's a 2, I'm not going to do anything. Here there's a 3, I'm not going to do anything. Here there's a 0, so I'm going to make it 2 zeros, and then move on. Then there's 4, do nothing. 5, do nothing, and then 0. Here I'm going to make it uh, 00. So that's what we want. We want that to be like, we want to duplicate the zeros um, in the output. So try this out. Input array should be this array with duplicated zeros. This should be our output. It's going to be this. So if we can do this, that will be part of our assignment this week. Okay, I'm going to stop. How like, any questions